So today we're looking at using those congruent triangles. We just talked about the one with the, so we have a river here, right? And we're standing here at the edge of the river with our little ball cap, right, or something. And we're kind of eyeballing across the river like that. And we've got this triangle. And then we just kind of turn and we look down the river this way. And we make this triangle. And those two triangles are congruent. And so this distance across and this distance across works out to be the same distance. Now let's think about when we might need some congruent triangles, okay? So let's say we've got the front of a car here. Here's a tire wheel. Here's a tire wheel. These are our front tires. What do we want our two front tires to do when we're driving our car? Do we want, okay, Logan? We want them to stay in alignment, right? Okay. When this one turns a certain amount, what do we want this one to do? We want it to match, don't we? What happens? You ever driven a car that doesn't? It's no bueno, is it? Okay, bad things happen. So those two wheels, let's draw them a little bit bigger here. They have a linkage that kind of looks like this. Well, it kind of comes in here a little bit easier and closer. And it's a triangular type linkage that hooks it all together. And so as this goes in, as this goes this direction, and it pulls this wheel in a slight amount, what happens to the point of this wheel? Does it get pushed out? And does it get pushed out exactly the same amount, right? And these two triangles, that's a terrible picture. So this would be the wheel, and actually the tire would be a lot bigger. But this linkage, it's hooked together, and it's a little more complicated than this, but the basic idea is when this one goes that way a little bit, so it pulls the tire in on the back of the tire a little bit, this one goes out, and so things will kind of match up a little bit. And these triangles, so the sides, we've got side, side, side congruence, okay? And then what happens though, can we change the size and shape of this triangle without changing the length of a side? We can't, can we? Okay, so one of these is a hydraulic arm that can go in and out, and it can lengthen the triangle side or shorten the triangle side. Okay, and so things have to work that way a little bit. But it's the triangles in those tires or in that steering column. And you guys take auto mechanics? Anybody in there? Okay. When you get underneath there and start looking at it, okay, some of it's kind of straight across and it works, but if you look at it, that's how it's working. Okay, let's look at the guy in the what is that? What is that, glider? Is that what it's called? Hang glider? Okay. Explain how you can use the given information to prove that the hang glider parts are congruent. Why do hang glider parts have to be congruent? So you don't die? Exactly. Yeah, I think I would be very afraid to fly in a hang glider that was not congruent. But, I mean, basically it looks like this, doesn't it? Angle 1, angle 2. And what else? So those aren't even in the triangles. So we have two triangles here. Angle 1 and angle 2 aren't even inside the triangles. Angle RTQ, this angle, which probably is a right angle. We don't know for sure though, it doesn't say. And RTS, are congruent. Do we have enough there to prove that those two triangles are congruent? Maybe not right now, but can we get there? Yeah. We don't have, angle 1 and angle 2 aren't in the triangle, but angle 1 and this angle right here, do they form a linear pair? So they're supplementary, right? Angle 2 and this angle right here, they form a linear pair, so they're supplementary, right? So what does that congruent supplements theorem say? If two angles are supplementary to the same angle or two congruent angles, then they are congruent, right? So these two angles aren't supplementary to the same angle, but they are supplementary to congruent angles, angle 1 and angle 2. So they've got to be congruent as well. Okay, now do we have enough? What do we got?
We need a side.
We need a side. What side can we get?
RT.
RT, right. They share that side in common. Reflexive property says that one's congruent to itself, of course. So now what do we have?
Now it's siding, angle, side.
Angle, side. Angle, side. So angle, and then the angles here, and then the side here. You really want to say, well, those are right angles, don't you? Do we know if they are or not? No. I mean, common sense says they probably are and everything, but we don't know for sure. Okay, let's look down at example 1 for a minute. Bottom of page 278. So this is something we talked about yesterday. We've got these two triangles, and we're given that AD is congruent to CD, and that BA is congruent to CA, or excuse me, BC here. And what we're supposed to prove is that angle A, we're supposed to prove this angle is congruent to that angle. Now there's really only one way to do this. Do you remember what it is? There you go. That one, right? But before we can use corresponding parts of congruent triangles are congruent, what do we have to show? The two triangles are actually congruent, right? Well, are they? How do you know? Side, side, side. Do we have side, side, side? Not quite. Can we get side, side, side? With what's given, what else would we have to say? Okay, awesome. BD is congruent to itself. Then we can say side, 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 right? Congruence. And then we can say angle A is congruent to angle C, and what's our reason? Corresponding parts of congruent triangles are congruent. Even though we write CP, CTC, I want you guys to say corresponding parts of congruent triangles are congruent. Okay, not, I don't know. This looks like the old Russian abbreviation. But anyway, you guys just made a plan to do that proof. Did we do the proof? No, we just made a plan. Now, you're going to be asked to give a plan, you know, give a plan for how you would do this. Well, I would say BD is congruent to itself, and then with that and the given information, I'd have side, side, side congruence between the two triangles, and then I could say these are corresponding parts of congruent triangles. Wasn't that our plan? That's all you have to say. That's the plan. You don't have to write out the entire proof or anything. You just have to give the plan to do it. Does that make sense? Okay, so a little bit nicer than normal. Let's look over at example 4. See the big river? Use the following method to find the distance across the river from point N to point B, P. Place a stake at K. Can everybody find K? Where's K at? Is it any special place? It's on your side of the river, right? Okay, so we've got our river. Okay, so we want to know the distance from point N. So from point N here, right there, over here to point P, we want to know this distance. So it says place a stake at point K. someplace down the river, on your side, you put a stake. Doesn't sound too promising so far, does it? No? I don't think so either. Okay. On the near side, so that NK is perpendicular to NP. Ooh, NK. So you want to go straight down here so that this is perpendicular. So what kind of angle we got right here? Okay, perpendicular lines make right angles. Find the midpoint of NK. Is that doable?
Yeah.
I think that's doable. I mean, if we went outside and we put two stakes so far apart, could we find and put a stake halfway in between? Yeah, we could do that. Okay, so there's our midpoint right there. Okay. Locate point L so that NK is perpendicular to KL. So you've got to come out here like this, and you've got to make this, so from point K, you've got to go perpendicular to NK, and you've got to walk out here, and you've got to place point L somewhere out along that line. Now the question is, where do you place it, right? Okay, so have you guys ever built a fence before? Who's ever built a fence before? Okay, so when I'm building a fence, I always put the first post in and I put the last post in where I want them, right? So that's the first thing I always do. And then my dad, this is how this always worked. My dad would stand down here by this post, right? And it's standing up like this, and then this was over here. And we'll just say the ground's like that. And then I would pace off however far it had to be, and I would stand off to the side, and I would hold this post up, and my dad would say a little left, a little right, and what was he doing? He was looking directly at this one, so that this one back here was hidden behind it, so they lined up, right? And then could he line me up, tell me where I needed that one to be? Yeah, he could line that up, and then, you know, you put the post pounder on it and you pound it in the ground, or you start digging your hole or whatever it's going to be, right? And you just keep doing that as you go along. And you can get those things on the money. You ever looked down a really long fence before and you're like, wow, that's really straight? Well, that's what we're going to do here. We might even want a pole here instead of a stake. So we know we want to get over to this point, which might be a tree or something like that, right? You keep walking down along here until what happens? Yeah, they line up. So you just kind of keep walking and looking until eventually, when you're standing here, this post or whatever, let's say it's a post, and this tree line up. Okay? Now, what do you think? Are these two triangles congruent triangles?
Yes.
They are congruent triangles, aren't they? How do we know? I mean, right now all I see is, well, we got one angle in common. What else do we have in common?
Angle, side angle.
We got an angle, side angle? I only see angle.
Well, if you do the midpoint and then...
Okay, what do midpoints do, guys? They divide it into two congruent pieces, don't they? That's the definition of a midpoint. It divides NK into two congruent segments, right? So there's a side. What else?
The angle and both sides of
Vertical angles. They're always congruent, aren't they? So we have angle, side angle congruence. And can we actually literally measure this distance right here? Yeah, we can, can't we? We can measure that distance right there. Okay? And then you know exactly how far it is across the river. Now let me tell you when they actually did something like this. During the Civil War, the South came across and they were actually fighting in the North. Okay, so General Lee brought his troops over. They were fighting in the North, but they got very bad defeat, and they had to retreat. And they got their backs up against a river. And they needed to get across that river So there's guys over here shooting at you, right? Is this something you want to do in the daytime? Probably not. Want to do it at nighttime. You got to have bridges to get all your stuff across. Remember, you got to take horses across. You got to take cannons across. You got to take wagons full of food and ammunition and stuff across. You got to take wagons full of all your wounded guys back across. You don't want to just leave them there, do you? Okay. So they built pontoons. They just built wooden pieces, which would just be like a log, and then a whole bunch of logs put across. And they just want to put them out into the river and just keep pushing. They'll put one out, and then they'll put the next one on it, and they'll push it out, and they'll put the next one on it, and they'll push it out, and then they just keep pushing them out across the river. And it kind of gets washed down, but then they'll grab it and pull it up, and eventually they get it across. But all these have to be made in advance. And then how many do they have to make? They have to make a lot of them, right? They can't just have one bridge. So they have to make them up here where they can't get shot at by the guys on this side. Okay, they make them all. It takes them about 3 days. The Union doesn't press the matter like they should have, actually, and kind of gives them time. They go out at night, they push a bunch of bridges across, and they're able to get across the river, get enough men across it that they can push the people on this side back a little bit, because it wasn't a big army over here, it was just a few, and they were able to get all their people across and retreat back to the south. And it actually prolonged the war about, I think, about 6 more months after that it went on. Probably, you know, how many thousands of people more died because they were able to do that. But have there been times when we were glad we could do that too, right? How many times in World War II did we have to cross a river like that? You guys know how many times? A lot. Because when the Germans were retreating, what did they do to every single bridge after they retreated back across the river? They blew it up, right? Okay. And then what did we have to do? Rebuild the bridge, right? Okay. You guys ever see you've probably never seen that movie. It's old. Okay. So let's make a plan for a proof. Example 3. I think this is something you guys are lacking in. I think so often you start doing a proof, you know, and you start trying to make statements and reasons and everything, and you have no plan. You're like my daughter when they were playing this video at the game the other day. It's some kind of weird farm thing, and you're a horse or a sheep or something, and you have to make, I don't know, you put the obstacles in the way, and then you have to get your person over and keep other people from getting over. Anybody ever played that game? Anyway, about halfway through, about 1 o'clock in the morning, I'm woken up by my daughter screaming, "I have no plan, I have no plan!" And then manic laughter as she dies. So that's how you guys seem when you're doing a proof and you come and ask me for help sometimes. I have no plan. You have to have a plan, right? So let's take a look at this here that we have. So we're given angle 1 and angle 2 are congruent, and angle 3 and angle 4 are congruent. And we're supposed to prove that triangle BCE, can you guys find it? Oh, this is E. That little, see the little triangle? BCE, that little guy, is congruent to triangle DCE, of course, which is this other little triangle. What's the deal with that? How are we going to do that? Well, let's look at what we have right now. What could we prove really easily? I can see a couple of triangles here that we could prove are congruent pretty easily. Can you guys see them? Which two?
You can do the 2 larger ones, but you can also do the
Okay.
2 smaller ones.
Ooh. Well, let's start with the 2 larger ones. CDA and CBA, those two triangles. Are they congruent?
Yeah.
How?
The angle side angle.
Okay, so they have CA is congruent to itself, plus angle 1 and angle 2 are congruent, angle 3 and 4 are congruent. Do we have angle, side, angle?
Yeah.
Okay, so the two big triangles are congruent by angle, side, angle. And if they're congruent, what does that mean about all of their corresponding parts? They're congruent. So that means CD is congruent to CB. Corresponding parts of congruent triangles are congruent. AB is congruent to AD. Corresponding parts of congruent triangles are congruent. This whole big angle up here is congruent to this whole big angle here. I'm not going to mark them because I don't know if that's relevant. But anyway, hey, we're getting somewhere, aren't we?
Yeah.
Okay, so now look at the two triangles we got to prove. Before, all we had was an angle. Now what do we have? Ooh, oh, plus, hey, whoa, whoa, whoa! They share a common side. Which side is that? Is that the angle side side? Or is that the side angle side? Which?
Side angle side.
Oh, so it's the good. It's the good side then, right? Not the bad side. So we've got a side here, and then we've got the included angle, correct? And then we've got the side here congruent to itself. So we have side angle side congruence for those two. Okay, so what's our plan? We show that CDA and CBA are congruent by side. Is that how we did it? Oh, it was side angle side. Angle side angle, there we go, angle side angle. And then we say these are corresponding parts of congruent triangles, and CE is congruent to itself by the reflexive property, so these two would be congruent by side angle side. Is that a plan? Okay. Until you can do that, there is no point in starting to write out the proof, starting to write statements and reasons, other than maybe write out what you're given, you know, and I'm given this. Okay, if you can't do that, then you're wasting your time doing more statements. You've got to have a plan. I know that's not how teenagers live your life, right? You're like, do what I want to do now, plan for the repercussions later. But that's how we've got to do geometry. So I hope that helps us with this. Turn the page over. Proving construction. Let's look at that for just a minute. Recall that you can use a compass and straight edge to copy an angle. So I gotta have a regular pen to do this. So we have some angle, whatever it happens to be. We'll just make it like this. And we've got this angle right here, and what I want to do is I want to copy and make another one with the exact same angle right here, right? So let's take a look. If I just draw a segment, so this is going to be my copy. You with me so far? Okay. And I come up here and make an arc, and then I come down here and make an arc. So that's our first step. And then our next step was to get this distance across here. Was to take our compass like that and find that distance like that, right? Okay, now you can do it either way, right? And then we come down here, make that distance like that, and then we just go like yay, and these two angles are congruent. And how do I know?
Because of the angle side angle.
That's how I know. Don't you think? I mean, let's look at this for a minute. A, B, C. X, Y, Z. What do we know about AC and AB compared to X, Z, and X, Y? They're all four of them are congruent, aren't they? All four of them are congruent. if I were to connect these, rather not just with an arc, but an actual segment, when I constructed it, didn't I construct it so that those two segments were congruent? So are these two triangles congruent? How? Side, side, side. And if they're congruent by side, 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 then what about their corresponding parts? They're congruent. So that's how I know that that construction works. So that's the proof of that construction. And we're going to look at all of the constructions that we've done, whether it was, you know, here's a segment, I want to find the midpoint. Remember finding the midpoint of a segment? I'll take your dead silence as a yes. Remember finding the midpoint of a segment? Yeah? Start here, start there, here, here, go like that. Hey, that right there is the midpoint of segment AB. You think? Okay. What do you guys know about AC and BC? Are they congruent? Yeah, they're on congruent arcs, aren't they? And then what do you know about AD and BD? They're congruent, okay? And in fact, aren't they congruent to these two as well? You see where I'm going with this? Yeah. Okay. All right, here we go. This should be fun and easy. Chapter 5.7. When I tell you guys the story about the Civil War stuff, I have to be careful not to actually mention the river or the date or anything like that, because if I say it wrong, Mr. Moulton will come over and correct me. Got to be careful.